I'm currently an educator at Level, powered by an academy. In this video, we are going to discuss an interesting problem with the name PS81. So, let me first tell you what you can expect from this particular video. Firstly, we would discuss the problem statement, then its input and output format, constraints. After that, we will see that how we can solve this particular problem. After that, we will see what should be our approach to solve this problem, and we will figure out the solution for this problem. After that, then we will move to the implementation of this particular problem along with the code. So let's just see what the problem says. Here, the problem statement says Alice and Bob are playing a jumping game. This time, Alice and Bob are standing on an infinitely long number line. Initially, Alice is at position O. Initially, Alice is at position 0 and Bob is at some position X. X can be negative, positive, or 0. Bob has to take exactly n jumps. So, guys, exactly. So, you can see here it is saying exactly n jumps, not less than or more than n. And each jump should be exactly d meter long. In each jump, Bob can go for position I to position I plus d or I minus d. So, Bob can either move d meters towards its right or d meters towards its left. Now, Bob's goal is to reach as near as possible to Alice in exactly n number of jumps. Bob is not good at math, so he asked you to print the minimum possible distance between Alice and Bob after n jumps. So we just need to find the minimum number. So here you can see we need to find the minimum number of So here you can see we need to find minimum distance possible between position 0 and the position of Bob. That would be after n number of jumps. Let's see what are the constraints here. So value of the test cases would be 1 to 10 raised to the power 5. Your x can vary from 10 raised to the power minus 10 to 10 raised to the power 10. Then next is your n and d, which can move from then next is your n and d, which can vary from 1 to 10 raised to the power 10. Now let's move forward and see the input format for this problem. So first line would be a single integer, that would be t, which is the number of test cases. And after that, each test case would contain 3 integers, x, n, and d. Initially, position of Bob would be the number of job. So that is x is the initial position of Bob, n is the number of job, n is the number of jump Bob have to take, and d is the length of each jump, right? What is the output format? So for each test case, output is a single line where you need to print the minimum distance between Alice and Bob after n jumps. So here is a sample input given to you in which there are 3 test cases. Now let's see how we can solve this particular problem. Here I have dragged your problem just for your reference. So what the problem is saying is that Alice and Bob are playing that particular jumping game. The time Alice and Bob are standing, this time Alice and Bob are standing on an infinitely long number line. Initially, Alice is at position 0. So we can have an infinitely long number line on which Alice is standing as some position 0. And let's say there would be some positions and there would be some positions on negative side also. And as we know, Alice is here at position 0. After this, Bob is at position X. X can be negative, positive, or 0. So Bob is at some position X. Now Bob has to take exactly n jumps and each jump should be exactly d meter long. And one jump would be of d meters. In each jump, Bob can go from position I to his position I plus d or I minus d. So for example, if x is here currently and let's say your jump is of 2 meters, value of d is 2. So either X can take a jump of 2 on its left side, or as well as it can take a jump of 2 on its right side. Next thing is, Bob's goal is to reach as near as possible to Alice in exactly n jumps. Bob is not good at math, so you need to help him and find the minimum possible distance between Alice and Bob after n jumps. Here I have taken a sample input and sample output for your reference. So in sample input there are three test cases. First is this 322, in which as your input format, first is the position of X, that is position of Bob. Second is your N, that would be your number of jumps. And third is D, that is the distance of every jump. Here, let's talk about your first test case, which is in which is this one, in which X is initially at 3. We have to take two jumps of distance 2. So if we are having this line, so we are talking about the first test case in which your X is 3, N is 2, and distance is also 2 of every jump. Let's say we are having this infinitely long line on which Alice is standing at a position 0, then 1, 2, 3, minus 1, minus 2, minus 3, minus 4. As we have to find the minimum distance between Alice and Bob, so right now, as you can see, X is 3, so Bob is here. To find the minimum distance, we would move Bob always towards Alice, that is towards origin, which is your 0. So we can take two steps here of distance 2. If we will make the first move of the distance, it would be here. This is your first move. And if you will make second move, and if you will make second move, it would be here. So we have made our two moves. Now what is the distance between Alice and Bob? So you can see Bob have reached here, and distance is minus 1 to 0, which is 1. So guys, which is 1. So here you need to remember that we are talking about distance but not displacement. Distance is a positive quantity. Distance is a quantity that would always remain positive, right? Distance can't be negative. That's why we would always take the absolute values of distance, right? So here you can compare with the sample output, which was 1. Our output seems to be right. Then let's check out the another case in which your X is minus 5, N is 3, and D is 1. Here, let's say this is your axis 0, 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4, minus 5. As we have seen, your X is minus 5, jumps are 3, distances of 1. So minus 5 is your X, N is equals to 3, and your distance of jump would be 1. So here we can say that Alice is at 0 and your Bob is at minus 5. So X is here at minus 5. Now you have to take 3 jumps and every jump would be of distance 1. So here if you will take 3 jumps, this is your first jump of distance 1, this would be your second jump of distance 2, and this would be your third jump of distance 3. Here you can see we have completed all our jumps till now. So this is the nearest possible place to Alice. What is our distance between Alice and Bob now? It is minus 2 to 0. That would be 2. As I have told you, we will always take the absolute value of the distance. And here you can see it matches our output too. So it's correct. Now your next case is that Bob is also at 0. It takes 2 steps of distance 2. So here, if it is like this, here we have X initially at 0, your N is equals to 2 and your D is equals to 2. So Alice is at 0, Bob is also at 0, your x is here, they are already at the same place, distance between them is already 0, but we still have to take 2 steps. Reason being it is given in the question that you that you would have to make n jumps in any case. So here we can say that Bob would take one jump away from Alice, and then it would take second jump towards Alice of distance 2, and it would come here again. So we can say the ultimate distance between Alice and Bob would be 0. Here you can see our output is correct, right? So we have seen that there can be some cases when we are taking Bob towards the origin, that is 0. So first is if you are able to observe that when Bob is at some position x, we are taking n steps of distance d. So total distance that would be covered so total distance that would be covered So total distance that would be covered in n steps of distance d would be n into d, as we are taking n steps and every step is of distance d. So total distance covered by n steps would be n into d. This is our total distance covered by Bob. Now, if this total distance n into d, if it is smaller than or equals to x, then we can say that Bob would be, so we can say that in that particular case, Bob would not be able to reach near. So in that case, we can say Bob would not be able to reach till 0, right? As we have seen in this particular case. Here you can see the total distance was n into d, which was 3 into 1 is equals to 3, right? So total distance covered by your steps was 3, which was from -5 to -2. But we haven't crossed your 0. So in this case, when we know that your total distance is either less than or equals to 0, in that particular case, we can find our this distance between Alice and Bob. It would be total distance where Bob is at. It would be the distance at which Bob is minus the total distance that you have covered, which is n into d. And it can give you the minimum possible distance, right? Because at max, because at max, Bob can reach till -2 only. It can't come nearer than -2 to origin. So this can be one case in the problem. So we can write here, if your total distance covered by steps is smaller than or equals to x, then your minimum distance would be equals to x minus n into d. We have seen our first case here. Now there can be another case when your total distance covered by steps would be greater than x. This is the case when Bob would cross your origin, that is 0. So we have seen this particular case here when Bob crossed origin and it came to -1, right? We have seen this particular case in third test also, that when we are already at 0 and we move 2 steps away from the origin, then we move 2 steps back towards origin, right? So let's see how we can handle this particular case. So you can see it like this, that if it is your origin and we have reached at some place this. And till now we have reached at some place like this. After that, let's say if we have even number of steps remaining. So if there are even steps and we want to come nearest to your origin, then we can firstly take that jump and then come back again, right? If you have even numbers, then firstly you will go there and then come back. So if this would be first step, then this would be second step, this would be third step, this would be fourth step, this would be fifth step, then this would be sixth step. So if there are even number of steps remaining, then ultimate position where you are coming earlier would always be equals to. In that case, you will always come here and your distance would be equals to, let's say, y. What this y would be? What this y would be? So if your distance x is not divisible by d, right? For example, let's say x is 10 and your d is 3, right? So if you will take the jump of 3, so if you will every time take the jump of distance 3, you won't be able to reach to 0. Reason being, 10 is not a multiple of 3. So if you will come, so let's say if your x is equals to 5 and your distance d is equals to 3. So if you will try to come at 0 from 5, so 5, 4, 3, 2, 1, 0, then minus 1, minus 2. From 5, if you will take a jump of 3 steps, you would come to 2. If you will take the next jump, then you would come to minus 2. If you will take the next jump, then you will reach at minus 1. So it doesn't matter how much you are trying, you would never be able to reach at 0, because 0 is not a multiple of 3, because your distance x is not a multiple of 3. So here we can just take the remainder. So here we can just take the remainder that would come every time when you will try to divide x by d. So if you will take modulo of x and d, so it would be 5 modulo 3, which would always be equals to 2. So here you can see how much you would try ever, this distance would always remain 2, right? This distance would always remains 2. So let's say if you have used till here your j jumps, so remaining jumps would be n minus j, right? Remaining jumps would be n minus j. If you are this factor n minus j, where j is jumps that you can make till here, which you can get by just doing x divided by t. This can give you the jumps that you can make till here. This will give you the jumps that you would make till here. So for an example, you can see if you will divide 5 by 3, so it will give you 1, that you can reach till here in maximum 1 jump. So in this particular case, your j would be 1. And let's say if your n is equals to 3, so we would be doing 3 minus 1, that would be 2. So remaining jumps left are 2. In this case, remaining jumps left are 2. So firstly, you will make a jump away from this, and then again you will come towards this, because we want to keep the distance minimum. So we will keep jumping from here and there on 0. Now there is an observation that you can make. If your jumps are odd, then you are going away and coming back again to the same position. So in that particular case, we can say that if the number of jumps left are even, then your ultimate distance is going to be x modulo by d only, right? Because that is the remaining distance between 0 to where you can reach nearest possible. But what if your remaining jumps are odd? So if, let's say, if your value of n would be equals to 4, and here the jumps that we needed was 1, so the remaining jumps would be n minus j, which would be equals to 4 minus 1 equals to 3. So if 3 jumps are remaining, you can see here, firstly, let me just erase this part which we have done for even jumps. So if remaining jumps are equals to 3, firstly you will go away by your first jump, then again you will come back, this would be your second jump, and again you would come, and again you would go away. So here you can see, if the total jumps are odd, then you would always be going on the other side of 0, right? So how we can find this distance? So if you can see this distance, so how you can find this particular distance which you have covered on the other side of 0? So if you can see, this distance would always be this total distance of jump minus this particular distance on the left side which was remaining, right? It will give you this particular distance, right? So how we can determine the distance in case of odd number of jumps? This was the distance. In case of even number of jumps left, in case of odd number of jumps left, what we can say, our total distance would be your this distance of jump, that is d, minus the distance that was remaining on left side. So it would be minus x modulo by d. It can give you the distance, as here you can see the distance of jump was 3 minus x modulo by d. It was giving you 2, 5 modulo by 3. So we got our answer as 1. And here also you can see it was the distance of 1 from minus 1 to 0, right? So this is how we have got our answer. Now, as we have seen all the possible test cases, what are the possible test cases? Firstly, you were not able to reach till 0 in the given number of distance. Firstly, you were not able to reach till 0 in the given number of steps. So here your minimum distance was equals to x minus n into d. Another case was that you are able to reach to near to 0, but you are crossing 0. In that particular case, we checks the number of jumps left. If the number of jumps are left, if the number of jumps left are even, then your remaining distance would be x modulo by d, which we have just seen. Otherwise, if the number of jumps left are odd, then it would be d minus x modulo by d, right? So now let's just see how we can code this particular problem. So here, if you will code this problem, firstly let's make a function which will give you the minimum distance. So function minimum distance, in which we would be passing firstly your x, that is the position of Bob. Next is n, which is your number of steps, and after that this is d, which is the length of one step. So as I have told you that your distance would always be absolute, it doesn't matter if x is lying on negative side or on positive side, the distance at the end between the final position of verb and 0 would be positive. So we can take your x as absolute number, that would always be positive. So mat dot absolute of x, because ultimately your distance is going to be positive. Now next thing that we can do is we can just check if the total distance covered by your n steps is greater than. Now we can check what is the total distance covered by your n steps. So, let total distance covered by n steps, it would be n into d. So we can check if this total distance is smaller than x. So we can check here if your total distance covered by n steps is still smaller than where Bob is. So here we can check. Now here we can check if total distance covered in n steps is either smaller than or equals to your x where you were lying earlier, then ultimately your answer is going to be x minus total distance, which would be the remaining distance you would not be able to cover. Otherwise, you can check that how many moves were there which were required. So let's say required moves are equals to total distance x divided by d. These were your required moves, and the remaining distance after making the x by d moves, and your remaining distance after making the required moves would be equals to, so remaining distance would be equals to your x modulo by d. It would give you the remaining distance. So we can check if your remaining moves, that is total moves n minus your required moves, if this number, so we can check if your remaining moves, that is, so we can see your remaining moves, that is total moves n minus your required moves. If your remaining moves are even, so if your remaining moves are even, so if your remaining moves are odd, that means if we will take the modulo of remaining moves by 2, it will give you 1 as remainder, right? So this is the case when your remaining moves are odd. As we have seen here, in case of odd number of remaining moves, what we have done, we have subtracted this remaining distance from total distance of one step. So here we can do the same. We can say your answer would be distance of one step minus your remaining distance, and as distance would always be positive, so we will return the mat dot absolute value of it. Otherwise, if your distance if your remaining moves are even, so in case when your remaining moves are even, your distance would be only your remaining distance. So in that case, you can return your remaining distance as your minimum distance possible. So let's just try this particular code on different cases. When one was when n is equals to 5, or let's say distance x is equals to 10, and you can only make moves of distance 1. So let d is equal to 1. Now let the minimum distance returned by your function min distance is x n and d, which we would be passing to it. And let's just console.log your minimum distance. Let's try to run this particular code if it works or not. So here you can see it is giving us 5. Let's see how. So your total distance was 10. You have taken one step. You have taken 5 steps of distance 1. So that's why it is remaining distance is 5. Let's say if we will take steps of distance 2. Then the remaining distance should be 0 because 5 into 2 is 10. So we would be able to cover the distance 10. Let's run it. So now you can see the distance is 0. It's working fine. Now what if your distance is 3? So 3 is not a so 3 is not a factor of 10. In that particular case, answer should be different. So here you can see the answer is 1, right? As we have seen, it is working fine. So we are done with this particular problem statement. The I hope the approach for this particular problem is clear to you and you would be able to solve this problem on your own now. Thank you. Take care.